So now we move on to proving the area of our triangle. So our theorem, again, what we want to prove is that the area of a triangle is 1/2 base times height, where b is the base and h is the height. And we start off by drawing this kind of triangle here. It doesn't really matter what kind of triangle it is, but for now, let's just say that this is a right angle triangle. Now we can rotate this triangle so that we make such a shape like this. It could be a square or a rectangle, which we have proven the area of before. So from here we know that the area of this ABC triangle is 1/2 the area of this whole square here, or rectangle, the ADBC. From here we know that this is the same thing from our theorem as 1/2 our base, which would be BC, times our height, AB. And now we can do this because from the properties of our rectangles and squares, these two lines are the same and are congruent, and these two lines are also congruent. Okay, so for this type of triangle, we've proven that the area is defined indeed as 1/2 base times height. Now we can move on to this type of triangle here. Just a regular type of triangle, nothing special about it. And we can see that if we split it up into two distinct triangles, we have two different areas. This one and this one here. Okay. And then from here we know that the area is a combination of the two. So it is the area of ABD plus the area of B. So now that we have this, we could say that this is equal to 1/2 the base, which is AD, times the height, which is BD. And for triangle BDC, we could say that that is 1/2 the base, which is DC, plus the height, which is BD. Now from here we could see that we could factor out a 1/2 and a BD. So from here on we could say this is 1/2 BD times AD plus DC. And if we look at our drawing here, that is 1/2 BD is our height, and then AD plus DC is our base right here. So that also proves that the area of this triangle is 1/2 base times height. Okay, now we have this other type of triangle, and we have an acute angle in this triangle, and we draw the right angle triangle right here. And so we know that the area of ABC could be described as the area of this whole thing, this whole triangle ADC, minus the area of this little thing, ADB. Okay, and then from here we could say that ADC is 1/2 the base of this thing, which is DC, times its height, which we know is AD, minus 1/2 of the base of this one, DB, times the height, AD. And from here again we could see that we can factor out 1/2 and an AD. So we are left with 1/2 AD and times DC minus DB. And what is DC minus DB? That is DC minus DB. DC minus DB, so this is the base of this one. So we have proven that the area of this triangle is also the base, BC, times the height, AD, and times 1/2 of that.